Well, welcome. In this video, we're going to be looking at the Central Limit Theorem. But before we get to that point, it's important for us to understand the purpose of having a Central Limit Theorem. Because a lot of times, we're going to be working with a population, a larger population, and it's not feasible for us to be able to test every single piece in that population. Like, for example, maybe we're doing a study on the average weight for adult males. Or maybe I'm a owner of a company where we make a certain vehicle, and I make a claim that my vehicle gets a certain gas, miles per gallon. And I'm a company that wants to test whether or not my advertisement is true. So if that's the case, that company is not going to be able to test every single one of the vehicles that I make. Instead, what they're going to do is they're going to test a smaller sample size. Or if we're making a study on all the average weight of the adult males, we're not going to be able to look at every single male in the United States population. We're going to be taking different samples from around the country. So there's going to be some different terms that we need to be familiar with while we talk about this. Now, we call this simple random sample, the SRS. That's just basically just saying that we have a sample size n that's chosen from a larger population, and each of those samples have the same likelihood of being selected. Now, the mean, that mu symbol, that mean represents the mean of our entire population. So if I was the owner of a company and I made an advertisement or made a claim that my vehicles get 30 miles to the gallon, that would be my average, saying that on average they get 30 miles to the gallon. That would be my mean. Now the X bar would represent the mean of my individual samples. So if I owned a factory and a company came in and wanted to test my advertisement, they would not test every single vehicle that I've made. What they would do is they would randomly select some of the vehicles coming out of the factory and test those vehicles and figure out what that average, what that gas mileage would be. So that would be the X bar, would represent the mean of our individual samples. Now let's say if I owned a number of different factories. A company might come in then and make a study on all of these different factories that I would own. And so the next symbol there that we have represents the means or the averages of the set of means. So take the mean basically from each factory. Or if we're studying a large population like the average weight of the adult males, maybe we would do a study in every single state. Well, that symbol would represent the average then of each of those states combined. And then the last symbol there would represent the standard deviation of the set of sample means. Well, now let's talk about what that central limit theorem is all about. So that's what this is saying. And basically the key here is that the central limit theorem states that suppose all random samples of a size n are selected from a population with a particular mean and a particular standard deviation. Then as the number of samples, as the value for n increases, the distribution of the samples is going to approach what we call a normal distribution, and with a mean, mu. And to find the standard deviation for that mean, what we would do is we would take the standard deviation for the entire population and divide that by the square root of our sample size, n. Well, the next thing we have to figure out is, well, what is a good sample size? What actually makes a standard distribution to be normal? Well, that's what's talked about in this graph or in this table. So in that information, basically the key there is to know, well, one of two things have to happen. Either A, they have to tell us that the population is normally distributed. But if they don't make that statement, we have to know, well, how to know whether or how large a sample has to be in order for us to be able to make a claim that it's normally distributed. And that's why I highlighted that. That's a key point, to know that our sample size has to be greater than or equal to 30 in order for us to be able to make a claim that it's normally distributed. If it's less than 30, we can't do these things that we're going to be working on. In fact, everything that we've been working on in this chapter so far has been dealing with situations that are normally distributed. So now we know that if they don't make a claim that it's normally distributed, we have to at least be working with a sample size of 30 or more items. So let's look at an example where we're going to be using this information. So here we have a manufacturer that claims that its fluorescent light bulbs have a mean life of 2,000 hours with a standard deviation of 300 hours. And a laboratory purchases 64 bulbs to test the claim because it's not feasible for them to test every single light bulb that this manufacturer has claimed, or that they've made. So this laboratory, they test 64 bulbs. We want to figure out what the shape, the mean, and the standard deviation for the sampling distribution would be for the mean when we're dealing with a size n of being 64. So first, for us to be able to describe the shape, we need to look at that size. So again, the size is 64. So since n is 64 and that's greater than or equal to 30, we know that this is going to be normally shaped. So it's going to follow that bell-shaped curve of a normal distribution. So next, let's look at the mean. To find the mean, now the sample mean is the same as the mean of our population. So this is going to end up being the same thing. So the mean is going to be our 2,000 hours. To find the standard deviation, that's where we have to do a little bit of work. That's where we have to use that formula that was in that table from up above, where we take the standard deviation of our population divided by the square root of the size of our population, or size of our sample, which would be 300 is our standard deviation of our population. Our sample size is 64, so we take the square root of 64, which we know would be 8. So 300 divided by 8 gives us an answer, 37.5. So our standard deviation would be 37.5 hours for our sample mean. Now, I want you guys to try this next one on your own. Again, it's not very difficult here. So why don't you guys take a minute, try this next one on your own. So pause the video and hit play when you're ready to check to see if you have the right answer. Okay, let's see how you did. So it says, recall that the heights of Norwegian men are approximately normally distributed with a mean of 183 centimeters and a standard deviation of 6.7 centimeters. For samples of size 40 randomly selected from this population, what is the shape, mean, and standard deviation of the sampling distribution? So let's start with this shape. So the fact that we're dealing with a size of 40 randomly selected men from that population means that our shape is going to be normal. Next, our mean is going to be the same as the mean for a population, which is 183 centimeters. And for our standard deviation, we're going to take and use the standard deviation for our population and divide it by the square root of our sample size. So we divide by the square root of 40, which when you do that on your calculator gives you 1.06. So our standard deviation would be 1.06 centimeters. So that's it. That's how simple this lesson is. So hopefully you found that to be pretty easy as well. So good luck now as you work on your assignment.